right. Now I have an announcement. Starting this weekend, I will be, or my availability will be a little restricted through Wednesday. That is because I am a member of an organization called ABET. That is the Accreditation Board for Engineering and Technology. So maybe a little bit of general knowledge here. So here, let me share their web page. So this is Accreditation Board for Engineering and Technology. ABET is the world's premier organization for accrediting engineering programs, computing programs, applied science programs, etc. And it has been there for decades, maybe, I don't remember, I mean, maybe like 80, 90 years. Any engineering program in the United States, if it is not accredited by ABET, no matter where that program is, MIT or Caltech, it doesn't really matter, they won't get jobs. So every engineering program has to be accredited by ABET. ABET also accredits computer science programs, computer information technology, computing programs in general, but no computing programs have to be accredited, but hundreds of them are accredited by ABET because it is prestigious. So I'm a member of ABET. I'm a commissioner in the Computing Accreditation Commission, and every year I lead a small team to an institution, and we look at their computing programs, whatever they want to get accredited, and see whether they should be accredited. And so this year, because of COVID, we don't have any real visit, a face-to-face visit, so we don't go to the campus itself. Instead, we are doing everything virtually. And that activity is starting this weekend. We already have the self-study report and everything. We have gone through all that. Now we are going to go to, virtually visiting the campus, and I will be very busy from morning till evening. There are meetings every day, and it lasts through Wednesday afternoon. So I may not be able to respond to your email messages promptly. So that is the first announcement that I have. Second thing is next week, next class, that is next Thursday, you have your second exam. So let me say a little bit, let me talk a little bit about the exam. Okay. All right, I have posted this document on the website. I'm sure you can see it now. So this will cover material that we looked at starting lecture 5 through this week. And you know what those things are. Like I have listed some of those or most of those topics here. Like last exam, there will be 2 questions that require you to write Java programs. I can tell you what those questions look like. The first question, it would look like this. The following new use case, and there will be some new functionality here. I will be giving you a use case here, and you need to design and implement that in the library system. So you must go through the design and implementation of the library system thoroughly. That should be one of your focuses for the study of the exam. And you must completely implement it. And the design and implementation should be consistent with the way things are done in the code. You don't have to submit any design documents. You don't have to submit any documentation of your code. I just want the working code. Okay. So your project should be named your last name exam2 Q1, and then you should put all the new methods any new methods that you create at the end of the class in which you are adding them. For example, if you are adding two methods M1 and M2 in the whole class, they must appear at the very end of the whole class after all the existing methods so that I can easily find them. There's something else I was going to say about that. I forget what it was. Okay, if I remember it, I will say that. It just escaped my mind. The second question is a refactoring question, and I will be giving you some code, and you need to refactor that code. That is the second question. And you should create two Java projects. So don't put everything into one project. So the first one should be called like this, and the second one should be named like this. So I will put these questions in a PDF file and put it under the exams folder. So you can open that and see what the questions are and write the code. The Java code that you need to use to start with would also be under the exams folder under content. And the other questions that are multiple choice, true, false, etc., they would be like a quiz like last time. And so you finish that quiz and then submit it. And you also should work on these two problems and submit the projects, the Eclipse Java projects into the Dropbox for exam 2. So okay, that is essentially what I have to say about the exam. So spend some time understanding the library system quite well. So that is the reason why I have put this question here, so that you will be focusing on that. You will understand where things are, how things flow between classes and stuff like that. Okay. Any questions?
When you say design and implement, do you mean draw a sequence diagram and then do the code?
Yeah, it should not be a very difficult sequence diagram. You don't, I mean, I'm not asking you to submit any sequence diagram or anything, any class diagram, none of that. So you might be able to just get a plan for the sequence of steps and do and implement your ideas. So it might take maybe about, I'm just guessing here, 10 minutes to understand what the problem is all about, and then maybe 20 minutes to kind of come up with a rough design. And then I am suspecting many of you will not actually draw a full-fledged sequence diagram, but have a sketch of how things should flow, and then see where the methods should be. And I know that this is an exam and you only have so much time. So it is not as if I will be asking something that requires a lot of new, how do I say this? A lot of original thinking. There has to be some original thinking, obviously, but it won't be something completely completely new. All right. Yeah. But you don't turn in any sequence diagrams, none of that. I just need the Java code. And you should, yeah, the other thing I wanted to say was you should not modify any of the existing code. You should only add stuff. Except, I mean, because you are adding a new functionality here, user interface will have to be modified. You will have to change a little bit here and there. But otherwise, in the back end, the business logic, you should not touch any of the existing fields or methods. You should simply add stuff. Okay. So you won't have to modify existing methods or existing fields. It would be simply new stuff going into some of the classes. Any other questions? Okay. All right. Okay, then let me stop sharing that and let me say a few things about the stuff that we did doing this week. Okay. Okay, we covered quite a bit of material this week, and one was using generics, and one of the things that might be confusing to you would be this stuff. Yeah, the way item list, which is the superclass of catalog and member list, is coded. The way it is coded, it is an abstract class because we don't want people to be instantiating item list because it cannot be a singleton. At least I don't know how to make it a singleton with all these generics in place. So that is one issue. And what confuses some students is this T and K. There are two parameters to this class. So you need to supply two generic parameters. One is T, the other one is K. The reason why we have this added complexity here is because there has to be a relationship between T and K. You cannot willy-nilly pass two arbitrary classes. For example, you cannot simply pass transaction for T and integer for K. Okay. Or book for T and member for K. They don't, there has to be some connection. What is that connection? K has to be the type of the identifier for T. Okay, so the relationship should be that K should be the identifier for T. That is the intention. And for that, we write T extends matchable K. What it means is T implements, I don't really know why the designers of Java used this word here. I'm not very, I mean, who am I to complain, right? I mean, I don't really like this kind of a terminology. They could have probably said instance of or something, but they simply, or maybe type of, or they could have invented something else that this is very confusing to me. And I'm sure some of you also find this a little disturbing. What it means is,
I had a question about that actually.
okay,
So why does it say extends when matchable is an interface? Shouldn't it
that is
say,
what I'm saying. I don't know.
okay,
Why do they do this? I mean, they could have simply said T type of matchable or something like that. That would have been This is in a totally different context. We are talking about an interface and a class. And why do you say extends? I don't know. I mean, it is very, very strange, but that is what they have.
Well, I think one way of looking at it is that this is an abstract class. This is basically another way of writing an interface. Isn't that right?
This is I mean, yeah, this type T should be implementing this interface. That's what we are saying. The type, the first parameter that you pass here, whatever it is, maybe it is book. Suppose you pass book and string, then book should be implementing the matchable interface with string as parameter. That is the meaning of this. And if you go back to the previous slide, we have done that. Book implements matchable for string. Then book qualifies to be passed if string is the second parameter, because book implements this interface. So string, yeah, sorry.
Instead of, let's say we wanted the generics to be extending a different class instead of implementing an interface, can we do that too, or does it only work with interfaces?
Maybe I don't know the answer, but I suspect it would be any entity like a class or an interface. That is, I may be wrong, but I will check it out. I think it could be a class too. That is my suspicion. I would be very surprised if it is not. Okay. Any other questions? Okay. So that requires a little bit of thought, because if you pass it like this, T comma K with no relationship between them, then the compiler will have a problem. When the compiler comes to something like this, when it sees such a method, it looks at the matches method here, and then it sees that the element is of type T, and how does it know that there is a matches method in this type T? And, oh, sorry, here, there is a promise that T implements the matchable interface. So, and the matchable interface has the matches method, and it takes a parameter of type K, where K is a string. So everything fits. And the other thing is, don't get the impression that this matchable has anything to do with the Java development kit. No, it is something we introduced because we know we can't really use equals in the search method if it is to be very general. So this was a way to circumvent the issues related to the equals method. So I think that is the biggest, what do you call, yeah.
What about the comparable interface?
I'm sorry?
What about the comparable interface?
The comparable interface. Okay, let me think about that. Yeah, that would work. That would have worked. That's a good point. That is something we should look at. Instead of inventing this, we could have done the comparable. But the problem is, let's see here. Comparable takes an object. I will think about it. Okay, so there are two things I need to think about. One is whether there is any. Oops, let me jot down those ideas. So first question is extends about. I need to look that up. The other one I need to check how comparable would work.
Wait, never mind. I don't think comparable would work because I don't think they would allow you to compare two different types of objects.
That is
Yeah.
true. That is a good point. But you can, yeah, that is a good point, which would mean that I need to again go ahead and ask each type what its type is, what its ID is. That's a good point. Yeah, I didn't think about it. Maybe we thought about this when we designed this, but my memory fails me whether we ever considered this at all, whether we considered comparable at all. The other one is, personally speaking, I would like comparable and equals to be consistent with each other. So that would be, yeah. Anyway, I think you have a good point, but I will definitely think about it a little more. Extents and comparable. In my opinion, that is the biggest nuisance with respect to, or this stuff. What it really means is the biggest hurdle. Java generics is very hard to understand. Well, some features of some languages are hard. And when you extend item list through catalog, one thing that will happen is the methods of item list are all kind of very general. Their names, like you won't have get, what do you call, remove book, or of course you don't want to put remove in item list anyway, maybe not, but you don't have things like insert book. So you need to redo those methods here, otherwise library will have syntax errors. So if you make changes to one part of the code, you should try to restrict its bad effects. So one way would be to redo all these methods, like public, Boolean, insert book, which should call the superclasses insert. That is something that you should do. Otherwise, library will now have compilation errors. Then I wanted to emphasize this big thing. Here, as I said in the video, this is one of the most important concepts you should get out of this course, in my opinion. When you have a code like this, when you have a piece of code like this where the issue method is in the book class and the same class is going to be used for both periodicals and books, right? We have this book type. Every book object has a type object that says whether it is a book or a periodical. This is poor design. Why is it poor? It is because when you have a method like issue, the behavior depends on whether it is a book or a periodical. And when you find such conditionals, depending upon the book type, you are doing different things. It is time to take a hard look at this. This is not object-oriented programming. I mean, this is, you are using an object-oriented programming language in a very traditional way. This is not how it is meant to be used. It is like you are one person and you want to go to work every day and you use a bus or something, that is not what you should be doing. You can't you can't have a bus parked in your driveway and then use it. It is Nobody does that, right? That is not efficient. Instead, you might want to use public transportation. You could use a bike. You could use a car or something, little more appropriate stuff. Similarly, when you have an object-oriented language, don't use it like a traditional language, a procedural language like C. That is what we are doing here. If the book type is periodical, do it one thing, otherwise do another thing. If you find that the behavior depends on a field or sometimes on a parameter, it is time to take a hard look and see whether you should actually have different classes, because the behavior of the object depends on exactly what is stored in a particular field or what comes in as a parameter. You will see this occurring again this semester in other contexts, but this is the first time that you are seeing it here. And when you have it, what the solution is to have multiple classes, each class having this issue method, and the periodical class will have this code, the book class will have this code, and you could put this code as common code in the superclass and then maybe call this from the issue method in the individual classes. So this is actually taking all these conditionals and then saying, no, I'm not going to have conditionals. I'm going to have different classes and let polymorphism and dynamic binding do its job to invoke the right behavior. Okay, that is really important. But sometimes, just because you have an if-else statement doesn't mean that you should have multiple classes. Okay, like if you're looking at somebody's salary and then saying, okay, the withholding is going to be so much, otherwise the withholding is going to be so much. I mean, there is no. I mean, that probably wouldn't be a case for splitting it into multiple classes. I mean, that may not be sufficient. So you can't really arbitrarily say, oh, I have a conditional, let me create new classes. No, that is not how it works. Unfortunately, this is not mathematics, where you have theorems and then say, oh, well, this is this meets this criterion. You can't really say, you can't have mathematical type results. You have to look at it and see whether it makes sense to split this into multiple classes. And then you will have a superclass. Sometimes if there is no common code, then you put the superclass method issue abstract. Otherwise, if there is some common code, you put it into the superclass method and don't make it abstract. Then, yeah, that is what is here. Okay. Then the other thing was regarding the visitor pattern. This is a a very nice pattern. What does it do? In the library system, we have introduced a hierarchy, and suppose you want to add more functionality we want to add more functionality that depends on this hierarchy. Then the visitor pattern is an appropriate thing to employ. What you do is actually very simple things you can do at the time of system creation. You create a visitor interface for the hierarchy, and you call it something like loanable item visitor. The typical practice is to write the word visitor, and in front of it, put the hierarchy name, like loanable item. Then every one of these classes, you put the accept method, and they all have the same signature and the same piece of code. That's very surprising, actually. It's an amazing, what do you call, an amazing idea. And that's plus maybe one more thing here. Where is it? Yeah, what I would also suggest is having one more method in the facade that loops through the objects in the hierarchy, and then for each object, call the accept method for this visitor. So the thing is, the objects in the hierarchy accept the visitor and they call the visit method. So it is a little roundabout way of doing things. Maybe just to emphasize the point, let me show you how it flows. So we have, I'm not going to draw a sequence diagram. Instead, I'm going to use some other techniques to show this. We have a number of objects, a large number of objects possibly in the hierarchy. Books, periodicals, CDs, DVDs, etc., everything that you can think of. They all have an accept method. So these are all objects in the hierarchy, right? So this is a collection of things. Maybe that this is the catalog. That is the idea. And there is this visitor class. So the library has been implemented. It has been working for a year maybe. And I'm saying now I need to do something on these objects. So I create a new visitor class. I don't need any new interfaces. I don't need to touch anything in the library system. This is completely new stuff. The only thing I need to touch is the user interface because I'm going to have a new command, right? So the user interface will have to be modified so that I can add a new command here. Okay. And what does this command do? It invokes that little method in the library object. So the library object is here. It has, of course, as you know, a large number of methods. And one of the methods is to take care of the visitor pattern. So that this simply loops through all these objects and calls their accept method. So everybody has that accept method. And so on. So this loop keeps calling the accept methods. And this object, this visitor class is instantiated. You have an object. So let's say this is the visitor class object. So the visitor object is here. And it has visit methods for all types. For everything that you have in the library, for every different type of loanable item, there is a visit method. So when you invoke this new command from the user interface, it calls this method and passes this object's identity here. So whoever this is, it is passed over here. And that object is passed to each of the accept methods. So this object, let's call it V1 for visitor 1. So V1 is passed to this, and this V1 is shipped to the accept method here, to the accept method here. Everybody gets that V1 reference, and each accept method does the same thing. They call the visit method here. So if this is a book, it will say v1.accept. So sorry, v1.visit, and it will pass itself. So if this is the book parameter, and if this is the book object, it will go here and execute the visit method here, come back. Then this goes back here. It takes the next object. If this is a periodical, it will go to the periodicals visit method. The accept method will call the periodicals visit method. It will do whatever it needs to do, come back, and then the accept method ends. This goes back. It picks up the next object. Maybe the next one is a DVD, and here is the DVD. And it continues. So every one of these objects can be processed here, and you can do whatever you wish here to come up with the new functionality. Okay, so that is the whole idea. It's a marvelous idea because everything is object oriented. You don't have any conditionals anywhere, right? It looks everything is dependent on the type of the object. You polymorphically call or use dynamic binding to call the right object here, and the object here uses the right type of parameter to select the method, because the types of the parameters are different. The appropriate method gets selected, because when you pass this from any one of these, if this is periodical, it goes to the periodical visit method. If this is book, it goes to the book method, and so on. So this is a great design pattern that you can use, but it is limited because you can only do things on a hierarchy. You can't make arbitrary changes to a system. That is wishing for too much. There is no such thing, I suppose, but this is still fantastic. You can simply add new functionality by writing this new class. That's it. And of course, you have to have that user interface modified, obviously, because you are accepting a new command now. Then what else? Actually, I don't want to get into too much more with visitor pattern. There is something called double dispatch, which is not supported in Java, which is not supported in C++. This essentially provides double dispatch. Okay, because you are dispatching in two different dimensions. One is, anyway, I don't want to get into that. That is too much at this point. So, okay, any questions? Okay.
Is this way more resource intensive than conditionals?
You see, when you have a, whenever you have dynamic binding, what happens is, let me go back here. I'm going to give you a roundabout answer because I think the short answer is possibly, but let me tell you what happens when you do dynamic binding. I need to clear stuff. Okay. Oops, that is the wrong. Okay. Give me a second. I don't know what I'm doing here with respect to sharing. Okay, that is what I should be doing. All right. Let me clear some stuff. Okay. See, when you have a hierarchy, like let's say this is class 1, class 2, class 3, and so on, and there is a method here, M, and you're extending stuff, okay, and you have something like C1 x equals new C3. Suppose you write like this and write x dot m. what happens? Well, the system has to check if there is an M here. If not, it goes and checks if there is an M here. If not, it goes and checks if there is an M here. So it has to traverse all these paths to check where there is an M. So that could possibly take some time. And it may be slower than actually checking if something is to do something. It may be slower. Okay. So what the compiler would do is inside each one of these objects, like the C3 object in C. Sorry, let me clear this. If you have a class C3 and it has a bunch of methods, it creates a table of methods and then says where the method is. Right. So the system has to search for a method here. If not, it has to go to the superclasses object and then check its method table. So it takes a while, possibly. But on the other hand, nobody uses object-oriented systems for efficiency. That is not the primary goal. The primary goal is that you want a paradigm that is more suited to application development. And people seem to kind of agree that the object-oriented paradigm is the best we have to implement the typical application that you see in the market. Okay, so that is the long answer to your question. Anything else? Okay, so don't be surprised if I don't respond to your email very promptly. I'll try my best, but there are so many things to take care of. I may or may not be able to get to your email on time. And the next week we have the exam. So please study that library implementation well. Maybe what you should do is take a few, take every command and then see how the whole thing flows. All right. And to look at a few methods in more detail for a couple of commands, look at the methods in more detail. For the others, definitely see how the methods flow so that you know where things are. Okay. Only when you study examples would you learn how to create new things. Right. Any questions? Okay, let me go ahead and create. I have already created the breakout